Hello everyone, welcome to this video on the Year 8 data handling revision notes that you've been doing over the last few lessons. So I'm going to jump straight in. Alright, so in the first lesson I asked you to do questions from 1 to 5, so I'm just going to go through the answers to those questions in this video. Alright, so you can have a watch of this, pause it whenever you need to, and just double check what you've done in the revision sessions to make sure that you've done things correctly. Okay, so calculate the range in the following list. So we should know that the range is the biggest value, take away the smallest value. Okay, so the biggest value in the list is 7. The smallest value is 2. Okay, 7 minus 2 is 5. So 5 is the answer. Okay, I won't spend too much time on that one because it's fairly simple. As long as you remember, range is biggest, take away smallest every single time. Okay, so for this one, the biggest number is 13, the smallest number is 4, 13 minus 4 is 9, okay, and that's it for range. All right, so if I went too fast there, you can pause the video and have a look at it, spend however long you need. Right, the mode then, so we need to remember that when we're talking about the mode, we are talking about the most common number, so the number that appears the most. Okay, so in question A, the mode is whatever number comes up the most, which is 13. Okay, 13 comes up twice, the others all come up once. So the mode for question A is 13. A little bit harder for question B, but just have a look through. All right, so there's 23 there and 23 there. Okay, but then when I look a little bit further, there's 22, 22, 22. So 22 comes up 3 times. Okay, and the maximum that any other number comes up is twice. So the mode is 22. Right, still on the mode then for this one. Okay, so state the mode of this group. Well, we've got 4 comes up twice and the number 5 comes up twice. So when we do this now, right, be careful. So the mode is not 4 plus 5, because that would give an answer of 9, wouldn't it? So you can either write 4 and then a comma and 5 to represent this both the numbers 4 and 5, or you can actually write 4 and 5. Okay, but you never write 4 plus 5 because that actually is 9, isn't it? And the mode can't be 9 because 9 doesn't even come up in the list. Okay, so that's the mode there anyway. Moving on then to the median. So I'll spend a little bit longer now. So we need to remember that the median is the middle value. Okay, but also remember it's the middle value when in order. So unless you put them in order first, the numbers, you're not going to be able to find the median. So the median value is not 7, because I can see the 7's in the middle of this list, but you need to rewrite the list in order. Okay, doesn't matter whether you do smallest to biggest or biggest to smallest. I'm going to do smallest first. So if I rewrite this list, I get 2, 4, 6, 6, and 7. Okay, now I can see that if I was to cross numbers off from either end in pairs, the median value is 6 for that one. Okay, and for question B, same thing again. I'm going to write numbers out. So 4, 5, 6, 10, 10, 13. Okay, so this time you'll notice that we don't get one number in the middle. So what we actually get is these two together are both of our middle numbers. Okay, so when this happens, we're looking for the number that's in between these two. This one's quite an easy one to work out. The answer is 8, because 8 is in between 6 and 10, isn't it? But if you're unsure, because it's not always going to be obvious what that middle number is, okay, if you're unsure ever, just add the numbers together and then divide by 2. And that'll give you the number in the middle, which is still definitely 8, okay? 6 plus 10 is 16, and then half of 16 is 8, okay? So if we get 5 numbers here, so if we get an odd amount of numbers in our list, there will always be one median left in the middle there. And if we get an even amount of numbers, okay, which we've got in this one, we'll always be going in between the two middle values. Okay, so that's how you do the median there anyway. And then on to the mean. Okay, so we need to remember to work out the mean, you add the numbers, first of all, and then you divide by the number of numbers. Okay, so you add the numbers together, then you divide by the number of numbers. Excuse me. So step 1 is we're going to add these up. Okay, so 7 plus 5 plus 6 plus 7 plus 3 plus 2. You might want to do that in the column method if you want. Okay, but 7 plus 5 is 12. Okay, plus 6 is 18. Plus 7 is 25. 28, 30. Okay, so all of those numbers together add up to 30, and there's 1, 2, 3, 4, 5, 6 of them. So we're going to do 30 divided by 6, which is 5. Okay, so the mean of those numbers is 5. Okay, another one for the mean now, so slightly harder because they're bigger numbers. So when I add these up, I'm going to do them in a column method instead, just to make it slightly easier. Okay, so 13, 44, and 20. So 7 plus 6 is 13, plus another 3 is 16, plus 4 is 20, so carry the 2, and we get 2, 3, 4, 8, 10, 12, okay? So it adds up to 120. There are 1, 2, 3, 4, 5 numbers this time, so we're dividing by 5. If you're unsure about that, then don't count up in your 5s until you get to 120. That's madness. Do the box method, isn't it? Bus stop method, sorry. So 5 doesn't go into 1, carry the 1 over. 5 goes into 12 twice with a remainder of 2. 5 goes into 24 times, so 120 divided by 5 is 24, and that means the mean of that list is 24. Okay, and then on to this question then. So this is mean of a frequency table now. So this says Mr. Gregory wants to find out how many hours Year 7 students spend on their mobile phones or tablets after school. He asks 200 students how many hours they spend in total per evening. The results are shown in the table below. Calculate the mean number of hours spent using mobile phones by Year 7 students per evening. Okay, so straight away for this one, we don't want to have to write them out in a list, because remember, frequency means the number of times something occurs, right? So this means 24 students spent 0 hours, 43 students spent 1 hour, and so on, okay? So what we're actually going to do for this one is we need to add an extra little column at the end, okay? And we should be multiplying these together. This was a shortcut method that we've learned, okay? So we need to multiply these numbers together, okay? So 1 times 43, obviously, is 43, okay? 2 times 88 is double 80 is 160, double 8 is 16, so that's 176 in total there. 3 times 27, okay, is 81, I believe, so 3 times 20 is 60, 3 times 7 is 21, that's fine. And then 4 times by 18 is 72, I think, so 4 times 10 is 40, 4 times 8 is 32, add them together, okay? So we always get that end column now, and from there we're going to use our total. So we've got the total here, look, so the sum of the frequency is 200, and we now need to work out the sum of these numbers as well. Okay, so put those in the column method if you need to. I'm just going to quickly type them in my calculator just to speed it up a little bit. Okay, but we're now going to add these numbers together, which is, according to mine, 43 plus 176 plus 81 plus 72 is 372. Okay, so the mean now is everything added up together, which is this total here, divided by the number of numbers, which is this total here, isn't it? Because frequency means a number. So an estimate then for our mean for this one, or the answer for our mean, sorry, is 372 divided by 200. Okay, so type that in the calculator. I got 1.86. Okay, and we're talking about hours spent. So 1.86 hours is what I got for that one. Okay, so that would have been what I wanted you to do for that first lesson on revision. So sections 1 to 5. All right, so yeah, you can obviously press pause and skip back and forth this video however you need to in your own time. Just make sure that you self-assessed what you've done. Okay, so that is it for the first 5 sections, right? So press pause and have a check of what you've done, and then press play when you're ready to go through the rest, please. Okay, welcome back then. So I've just put this here because this is, I've split it up to how I've asked you to do it in the lesson basically, but it makes no difference anyway. So moving on, all right, this is the next section now. So this is still mean from a table, but it's discrete grouped data. Okay, so we're still talking about frequency, but here now, the data that we're using is in groups, right? And we're saying it's discrete because they're whole numbers. So what you needed to remember about this one was we want 2 extra columns, okay? The 2 extra columns are always the midpoint and then the midpoint multiplied by the frequency. Okay, so the midpoint is the midpoint of the groups. Okay, so similar to how I said earlier on in this video about finding the median of two numbers, you add them together and divide by 2. It's the same thing for this midpoint as well. So if you're unsure about what the midpoint's going to be, then add the two numbers together, so 0 plus 4, and then divide by 2. Okay, so the midpoint is 2 for that one, and the midpoint is 7 for this one, 12 for this one, and then 17 for this one. Okay. So compared to the last question in section 5, this is a different starting point, isn't it? We've got to find the midpoint first. But once we found the midpoint, which we've done now we do the same thing as last time, and we multiply these numbers now by the frequency. Okay, so we're going to multiply both numbers together next to each other and just write the answer in this column here. Okay, so 8 times by 2 is 16. 15 times by 7 is 105, I believe. 10 times 7 and 5 times 7. 13 times by 12 is 156. And then 4 times by 17 is 68, I think. Double check. Yeah. Okay. So you find the midpoints, then you multiply the midpoints by the frequency. Now we're still going to do the same thing as section 5 now. We need to find our totals and divide them. Okay, and the totals we're going to use, we're going to do the total frequency like we did last time. We're going to do the total of this end column here. Okay, so we're just going to add these together now. So 8 plus 15 plus 13 plus 4 gives us a total frequency of 40. And then if we add these up in the end column as well, you should have done that. So 16 plus 105 plus 156 plus 68 is 345. Okay, and then for our mean, we know we're going to do 345 divided by 40. Okay, so that answer then is 8.625. Okay, so that's part A done. Part B says state the modal class interval. So modal, it sounds similar to mode, doesn't it? So what this means is what group does the mode end in? Okay. All we need to think about for this one is, remember, mode is the one that comes up the most. So in this table, the modal class interval is the class interval that's got the highest frequency. Okay, well, the highest frequency is 15, and that corresponds to the group 5 to 9. So that is the modal class there, is the group 5 to 9. Okay, because there are more plants in this group than there are in any of the other groups. Okay, so that's how you do that one. Moving on then, so similar sort of thing here. So it looks very similar, other than the values here are a little bit different. So this is now continuous data. Okay, so there can be many values in between 50 and 80 here because we're talking about time, all right? But all you've got to remember is that your workings out are going to be exactly the same. Okay, we're going to find the midpoint, and then we're going to do midpoint times frequency, then divide the totals. Okay, so again, if you're unsure about finding the midpoints, then just add the numbers together and divide by 2. Okay, so 50 plus 80 divided by 2 gives you 65. So that's the midpoint there. Okay, do the same for the next one then if you're unsure. So 80 plus 110, and then divide that by 2 is 95. Okay, 110 plus 140, and then divide by 2 is 125, and then 140 plus 170, then divide by 2 is 155. Okay, so we've got the midpoints. Now let's do the multiplying as we should have done next. So 2 times 65 is 130. Okay, 38 times by 95 is 3,610. 9 times 125 is 1125, and then 1 times 155 is obviously 155. Okay, so same steps as last time. Now we find the sum of this column and the sum of this column. Okay, so the frequency, I believe, is 50. Right, 2 plus 38 is 40, and then add another 10 is 50. And then for this column, use the calculator, so 130 plus 3610 plus 1125 plus 155. We get 5020. Okay, So an estimate now for our mean will be 5,020 divided by 50, which is 100.4. Right, and that is in seconds because that's what we are talking about in this question. Okay, so that is how we do that question. Moving on then, so same data now I believe, but it's talking about a bit of more information here. Look, so it says calculate an estimate for the range of these data. So for the range, we want to be talking about the midpoints really, because we don't actually know what the values are in here. Okay, so our midpoints again were 65, weren't they? 95, 125, I think, and then 155. I'll just double check. 65, 95, 125, 155. Good. Okay, so when we do the range now, all we're going to do is we're going to do the biggest midpoint, which is 155, take away the smallest midpoint, which is 65. Okay, because we have to use the midpoints because we don't actually know what values we're talking about here. Look, this 50 to 80, we don't know what values are actually in there, what two numbers are in there, so we're just going to use the midpoints. Okay, so an estimate for the range, sorry, is 90. Modal class, the same as in the previous section. Okay, it's the one with the highest frequency. Look, so it's this one. So our modal class is when t is between 80 and 110. And then for the median, right, if we think about this now, we said that the frequency added up to 50, didn't it? The median is the middle value. So we've got to imagine now that if we're talking about 50 things, our middle value would be the 25th number, wouldn't it? So we've just got to find which group the 25th number would be in. Okay, there's only two numbers in the first group, so it can't be that. Then there's another 38 numbers in the second group. So by the time we get to the end of this second group now using this data, we would have used 40 pieces of data. So the 25th value must be within here, mustn't it? And we know it's not in the first group because that's only up to two values. So it must be in this second group somewhere. Okay, so we just say because of that, it's the 25th value, and the 25th value, when we put these in order, will be in this group. Okay, moving on then. So probability. I've got some chocolates in a box. Okay, 3 are white, 1 is dark, and 6 are milk. Chocolate is chosen at random. Work out the probability that the chocolate is white. So first of all, okay, there are 3 white chocolates, and there are 10 chocolates in total. Okay, 3, 4, 10. So that's 3 out of 10. Simple. Okay, dark chocolate. Well, there's only 1 dark chocolate, and there's still 10 chocolates in total, so that's 1 out of 10. For not dark now, there's 2 ways of doing it. You can either add up the white and the milk, or because you already know that there's 1 out of 10 is dark chocolate, that means the 9 out of 10 must be not dark chocolate because there's 10 in total. Okay, and then white or milk, remember that the word or means to add, doesn't it? So the probability of getting a white is 3 out of 10. Right, the probability of getting a milk, 6 out of 10. So adding those together gives you 9 out of 10. So saying white or milk or saying not dark is actually the same thing in this question. All right, so really simple, the number of ways of getting what you want on the top and the number of possible outcomes on the bottom. Okay, the not rule this time then, so still probability. So the probability of Mr. Tucker allowing students to wear trainers with the new school uniform is 0.002. What is the probability of him not allowing students to wear trainers? So there are only 2 possibilities, aren't there, with this? He will either let people wear trainers or he won't. Okay, we know the probability always adds up to 1. So all you need to do for this one, and I'm going to do it using the column method, is just take this probability away from 1, because then whatever's left over must be the probability that we're looking for. All right, so we're going to have to do some borrowing, aren't we, because we're subtracting. So this will become 10, but then 9. This will become 10, but then 9. And this will be 10 here. Look, so 10 minus 2 is 8. And 9, 9, 0. So we say that the probability is 0.998. Okay, moving on. Still the not rule then, but fractions this time. So the probability of Mr. Tenby's horse finishing the race in the Grand National is 2/15. what is the probability of the horse not finishing? So again, there's only two things that can happen. The horse will either finish the race or it won't finish the race. There's no in between. We know probability adds up to 1. In this case, adding up to 1 means adding up to 15 out of 15, because that's what 1 is in this question. So all we're doing is subtracting these two from each other, look. So if there's a 2 out of 15 chance that it does finish, there must be a 13 out of 15 chance that it doesn't finish. Okay? So again, any of those that have been a little bit too fast for you, you can always pause the video, move forward and backwards in your own time, all right, and make sure that you've got those marks, please. Okay, moving on then, so just for the last sections, this is what I gave you in the third lesson of revision to do now, okay, so just work our way through these answers as well. So mutually exclusive events, first of all. So question, section 10, probability Newport County win their next home match is 0.42, and the probability they lose their next home match is 0.37. Calculate the probability that Newport County draw their next home match. Okay, so mutually exclusive, remember, means that it's like an independent event. So based on what happened before has no effect on this outcome. Okay, so the probability of Newport County, or the possibilities for Newport County in the next home match, is either win, lose, or draw, isn't it? And we've already discussed in this video the probability always adds up to 1. So if they can win is a 0.42 chance and lose is a 0.37 chance, then the probability that they draw must be whatever else we need to make this add up to 1. Okay, so the way that you should have done this one is add up to that you are already given, so 0.42 plus 0.37, okay, which is 0.79, and then you should be doing 1 take away 0.79, okay, which is 0.21. So the probability that they draw the next home match is 0.21. Okay, so just remembering that fact, that they're the only 3 possibilities, and that they can either win, lose, or draw. And it's about remembering that fact that really adds up to 1. Okay, moving on then. So listing outcomes, right? A coin is tossed and a spinner with numbers 1 to 5 is spun. List all the possible pairs of outcomes. Okay, well, possible pairs of outcomes. I think the best way to do this is by doing either a list or a sample space diagram. I'm going to do a list for this one, okay? So on the coin, there are 2 possibilities, aren't there? We can get heads or we can get tails. And on the spinner, there are 5 possibilities because it's the numbers 1 to 5. So 1, 2, 3, 4, 5. Okay, the best way to do this, in my opinion, would be start with all the possibilities that you could get with heads and then do the same with tails. So we could get heads and 1, heads and 2, heads and 3, heads and 4, and heads and 5. Okay, then you can get exactly the same thing with tails. So tails and 1, tails and 2, tails and 3, tails and 4, tails and 5. Okay, and a good way of checking whether we haven't missed any of the outcomes out is if you multiply the possibilities together. Okay, so in this first event here, tossing the coin, there are 2 possibilities, aren't there, heads or tails. In the second event, which is the spinner, there are 5 possibilities, and 2 times by 5 gives you 10. So that indicates there should be 10 possible outcomes, okay, which there are here. We've got 5 including heads, and we've got 5 including tails, okay. Then part B, says what is the probability of throwing a tail and a 4? Well, there's only 1 tail and 4 together in this question, in these outcomes, which is that one there. So there's 1 out of 10. Okay, there's one way of getting what we want out of 10 possible outcomes. And then for part C, similar sort of thing. What is the probability of throwing a head and the spinner landing on an odd number? So we need to now think of, I'll do it in a different color, what possibilities we've got where it's a head and an odd number together. So that's one of them. Heads and 1 would work, wouldn't it? Heads and 3 would be fine, and heads and 5 would be fine. Okay, so that is a 3 out of 10 chance, because there's 3 ways of getting what we want out of 10 in total. Oh, excuse me. Okay, moving on then. So experimental probability now. So Mrs. Hayder designs a spinner that has 4 sections coloured red, blue, green and yellow. She decides to test to see if it's fair. Mrs. Hayder records the results in the following table, so we can see it here. All right. It says calculate the relative frequency or the probability, experimental probability, that Mrs. Hayder's spinner lands on a blue section. Okay. Well, we can see here, remember, frequency means a number, doesn't it? So we can see in the table that her spinner has landed on the blue color 47 times. Okay. But that is 47 times out of however many times she spun it in total, which would be the total frequency, wouldn't it? So if we add together 61, 47, 35, and 57, we get 200. Right, so there's a 47. This table is saying that the spinner has landed on blue 47 times out of 200. Okay, if we want to do it then as relative frequency, best to do it as a decimal. All right, so if we type into the calculator 47 over 200, all right, that is 0.235. Okay, so that's the relative frequency of doing getting a blue section on Miss Hayder's spinner. Okay, moving on then. So still the same table now, so just a different question. Calculate the relative frequency that Mrs. Hayder's spinner does not land on a green section. So there's two ways of doing this, isn't there? We can either add up the other three sections, or because we already know now that this is out of 200, okay, if it lands on green 35 times, then it must not land on green 165 times. If we just take that 35 away from 100, okay? And then again, 165 over 200, if you want to change that into a decimal, just type it into your calculator. That's 0.825. Okay, so the relative frequency that it doesn't land on a green section is 0.825. Okay, and then last one for this one. All right, so this says state whether you think the spinner is fair or biased. You must give a reason to your answer. So if this was a fair spinner, what you've got to think about is what you would expect to happen if it was fair. Okay, so there's four different sections here, and it's been spun 200 times. Okay, so really, if this was a fair spinner, you would expect the probability for this one to be a quarter, probability for this one to be a quarter, and then so on. You'd expect them all to be a quarter, wouldn't you? Because that would mean that it would be fair, because that would mean it's the same chance of each number coming up. So a quarter of 200 is 50, isn't it? So a quarter of spinning it 200 times is 50 times. So we just need to look at this data now and see whether we think it's biased based on how far away it is from 50. Okay, this one is above 50 by 11. This one is below. Okay, and we know this is just what we're expecting to happen. We know that it won't be exact every single time. Okay, so this one's slightly above. This one's pretty close, slightly below. This one's quite a bit below, and this one is a little bit higher as well. So I would say for this one that the spinner is biased. Okay, and simply what you could say is, looking at this data, there's either more chance that it lands on red than any other, or there's less chance that it lands on green than any other. Okay, so either of those two things would be fine, really, as your reason. So I'm going to say that it's biased because these are too far away from 50, in my opinion. Okay, so I would say biased because I would say there is more chance of getting, and I'll just pick red for example, red than expected, because remember we said the expected outcome was 50, wasn't it? So something along those lines. All right, so you just need to think about what the outcomes would be if it was fair, and then compare those to what the actual outcomes are. Right? It's never going to be exact, we know that. Okay, next one then. So this says this is expected outcome. So sort of following on from the last one. This says a coin is tossed 350 times. How many times do we expect the coin to land on a head? Okay, well, first of all, we know that tossing a coin is a 1 in 2 chance of getting a heads in there. So if you do it once. So all this type of question means is if we're doing it 350 times, then just multiply by 350. Okay. So 1/2 multiplied by 350, right? That's the same as just half in 350. Okay, so if you want to do 350 divided by 2, that's completely fine. So you would expect heads to be 175 times. Now we know in reality that wouldn't that wouldn't really happen, wouldn't it? Just because you tossed a coin 350 times, that doesn't mean you're going to get exactly half of them as heads and exactly half of them as tails. It could happen, but it's just unlikely. But this is what we are expecting to happen. Okay. Similar for this one now. So a fair die is rolled 300 times. How many times would you expect to roll a 6? So again, probability of doing this first of all. Okay, so this time the probability of rolling a 6 is 1 out of 6, isn't it? Because there's 1 6 out of 6 in total. That would be the probability of it rolled once. So if we're rolling 300 times, then we're just going to multiply. Okay, so 1/6 times by 300 is the same as doing 1/6 of 300. So remember, divide by the bottom times by the top, or just type in your calculators. It's no big deal really, but the answer is 50. Okay, so you would expect the number 6 to come up 50 times out of those 300 rolls because of what we already know about the probability of getting a 6. Okay, it's unlikely that that would happen every single time, but it could happen. Okay, and then last section then, so the probability that it rains on any given day in April is 0.4. How many days in April do we expect it to rain? So this is still a similar sort of thing, only the probability is given to us as a decimal. So the probability of it raining in April is 0.4. It says on how many days in April do we expect it to rain? So this is relying on the fact that you knowing that there are 30 days in April, okay? So if there's a 0.4 chance on one day, there must be a 0.4 multiplied by 30 chance on 30 days, okay? So that is 12. So over the 30-day period of April, we would be expecting it to rain on 12 days based on this probability, okay? So that is the end of this video now for the data handling revision notes. So like I've said, if you need to pause at any point and go back and forth, just make sure that you've checked the answers that you've done over the last few lessons on your revision, just to make sure that you've made no mistakes and you've understood the topics basically. Okay, thanks for listening. See you guys soon.